A data challenge a day helps you master machine learning. This is DDC 23, distributions of MNIST pixel values. So I refer you back to DDC 22. That's where we imported the MNIST dataset and created the average of each of the digits. And now what you want to do is import the same data so you can copy code from the previous DDC. But now, instead of showing images, you want to show distributions of all the pixel values using numpy.histogram. For some variety, I recommend not using pandas like you did in the previous DDC. Instead, only use NumPy here. And then you use NumPy.histogram to create the density distributions of pixel values from all the images. And then you can show the visualization in a plot like this. Keep in mind, most of the pixel values are either very, very small or very, very large. So you might want to manually adjust the y-axis limits just to make the rest of these look uh, visible. If you scroll down on this post, you can see a funny picture, and then you get the full solution here, which I will show you it now. So we do not need pandas here, we need NumPy and matplotlib. Here I import the data. Here I'm defining the bins that I will use for the histogram, and then I'm getting all of the MNIST samples for each of these numbers. Notice that because we're using NumPy and not pandas, the code looks different here compared to the previous DDC. Here I extract the histogram, and then here I generate the plot using the plasma color map. And then I am making it look a little bit nicer. Now here you can see if I comment out this part, or actually just delete this part, then the y-axis limits are scaled by these enormous values at 0 and 1, and the rest of the plot is just completely invisible. That's why it's often a good idea to be mindful of the axes and see if you want to adjust them. Pretty interesting to see that different numbers have global offsets of values.